Top 25 Gearbox Interview Questions and Answers. A gearbox is one of the most important parts of any mechanical power transmission system. It controls speed, torque, direction, and smooth movement between a motor and a driven machine. In interviews, employers often test your understanding of gear types, lubrication, failures, maintenance, alignment, noise, backlash, and troubleshooting. These gearbox interview questions and answers are designed for mechanical technicians, maintenance engineers, production engineers, automobile candidates, and industrial workers. Each answer is simple, practical, and useful for real job interviews. Use them to revise confidently before your next interview. 1. What is a gearbox? A gearbox is a mechanical device used to transmit power from one shaft to another while changing speed, torque, or direction. It contains gears, shafts, bearings, seals, and lubrication. In machines, it connects the motor to the driven equipment and helps control output performance. Gearboxes are used in vehicles, conveyors, cranes, turbines, pumps, mixers, and many industrial production systems. They improve efficiency, reliability, and safe machine operation daily. 2. What is the main function of a gearbox? The main function of a gearbox is to transfer mechanical power while adjusting speed and torque according to machine requirements. When speed is reduced, torque usually increases, allowing heavy loads to move easily. When speed is increased, torque may decrease. A gearbox also helps change direction, control motion, protect the motor from overload, and provide stable operation in different working conditions. This makes machine operation safe and controlled. 3. What are the main parts of a gearbox? The main parts of a gearbox include gears, shafts, bearings, housing, oil seals, gaskets, lubrication system, keys, couplings, and inspection covers. Gears transmit motion, shafts carry the gears, and bearings support rotation. The housing protects internal parts and holds lubricant. Seals stop oil leakage and prevent dust entry. Each part must work correctly to ensure smooth, quiet, and reliable gearbox operation. Regular inspection keeps these parts working safely. 4. What are the common types of gearboxes? Common types of gearboxes include spur gearboxes, helical gearboxes, bevel gearboxes, worm gearboxes, planetary gearboxes, and reduction gearboxes. Spur gears are simple and economical. Helical gears run smoother and quieter. Bevel gears change shaft direction. Worm gears provide high reduction ratios. Planetary gearboxes are compact and strong. The selection depends on load, speed, space, and application. Correct selection improves durability and efficiency. 5. What is the difference between spur and helical gears? Spur gears have straight teeth that are parallel to the shaft axis, while helical gears have angled teeth. Spur gears are simple, cheaper, and easy to manufacture, but they can be noisy at high speed. Helical gears provide smoother contact, higher load capacity, and quieter operation. However, they create axial thrust and need stronger bearings. Helical gears are preferred in heavy and high-speed machines. Correct selection reduces maintenance problems. 6. What is a worm gearbox? A worm gearbox uses a worm screw and worm wheel to transmit motion between shafts, usually at right angles. It provides a large speed reduction in a compact design. Worm gearboxes are commonly used in lifts, conveyors, hoists, gates, and indexing machines. They run smoothly but can generate heat because of sliding contact. Proper lubrication is very important to reduce friction and wear. Cooling and inspection remain important. 7. What is a planetary gearbox? A planetary gearbox has a sun gear, planet gears, planet carrier, and ring gear. The planet gears rotate around the sun gear, giving high torque in a compact size. Planetary gearboxes are used in robotics, automobiles, wind turbines, servo systems, and heavy machines. They provide good efficiency, load sharing, and accurate motion. Their design is strong but requires precise manufacturing and correct lubrication. Balanced loading improves service life. 8. What is gear ratio in a gearbox? Gear ratio is the relationship between the number of teeth on the driven gear and the driving gear. It shows how much the speed or torque changes inside the gearbox. For example, a high gear ratio reduces output speed and increases torque. Gear ratio is important for selecting a gearbox because every machine needs a specific speed, load capacity, and output performance. Correct ratio prevents poor machine performance. 9. How do you calculate gear ratio? Gear ratio is calculated by dividing the number of teeth on the driven gear by the number of teeth on the driving gear. For example, if the driven gear has 60 teeth and the driving gear has 20 teeth, the ratio is 3:1. This means the output shaft rotates 1 time for every 3 input rotations. The same ratio also shows torque multiplication and speed reduction. This is fundamental. 10. What is backlash in a gearbox? Backlash is the small clearance or free movement between mating gear teeth. It is necessary because gears need space for lubrication, thermal expansion, and smooth operation. Too much backlash causes noise, vibration, poor accuracy, and shock loading. Too little backlash causes overheating, tooth wear, and seizure. Backlash is checked using dial indicators, feeler gauges, or manufacturer-recommended inspection procedures. Correct adjustment improves accuracy, reduces noise, and protects gear tooth life. 11. Why is lubrication important in a gearbox? Lubrication is important because it reduces friction, heat, wear, and corrosion between moving gearbox parts. It forms a protective film between gear teeth and bearings. Lubricant also helps carry away heat and remove small metal particles from contact surfaces. Without proper lubrication, gears may overheat, become noisy, wear quickly, or fail completely. Correct oil grade, level, and cleanliness are essential. Routine oil monitoring greatly improves gearbox service life. 12. What are the common causes of gearbox failure? Common causes of gearbox failure include poor lubrication, wrong oil grade, oil contamination, overloading, misalignment, bearing failure, overheating, improper installation, excessive vibration, and worn gear teeth. Lack of preventative maintenance is also a major reason. If small problems like leakage, noise, or high temperature are ignored, they can become serious failures and stop the complete machine or production line. Good inspection habits reduce breakdowns and improve maintenance planning accuracy. 13. How do you identify gearbox bearing failure? Gearbox bearing failure can be identified through abnormal noise, vibration, overheating, rough rotation, metal particles in oil, and shaft looseness. A damaged bearing may produce humming, grinding, or knocking sounds. Technicians often use vibration analysis, temperature checks, oil analysis, and physical inspection to confirm the problem. If bearing failure is detected early, major gear damage and unexpected breakdowns can be avoided. Early action saves bearings, gears, and production time. 14. What causes noise in a gearbox? Noise in a gearbox may be caused by worn gear teeth, incorrect backlash, poor lubrication, bearing damage, misalignment, loose bolts, overload, or gear tooth pitting. Sometimes, noise appears after incorrect assembly or wrong gear contact pattern. High-speed gears naturally make some sound, but sudden loud noise is a warning sign. The cause should be checked quickly to prevent serious mechanical damage. Early diagnosis helps avoid costly shutdowns later. 15. What is gear tooth pitting? Gear tooth pitting is a surface damage where small holes or craters appear on gear teeth due to repeated contact stress. It usually happens when lubrication is poor, load is too high, or gear material is fatigued. Early pitting may be minor, but severe pitting can create noise, vibration, and tooth breakage. Regular inspection and correct oil selection help reduce pitting problems. Proper load control prevents this damage from spreading. 16. What is gearbox overheating? Gearbox overheating means the operating temperature becomes higher than the normal safe limit. It can happen because of low oil level, wrong lubricant, excessive load, poor ventilation, bearing failure, misalignment, or dirty oil. Overheating reduces oil viscosity and increases wear. If the temperature remains high, seals may fail and gears may get damaged. Temperature monitoring is important during maintenance checks. Cooling, ventilation, and oil checks solve many overheating problems. 17. How do you check gearbox oil level? Gearbox oil level is checked using a dipstick, sight glass, level plug, or manufacturer-specified method. The machine should be stopped safely and allowed to settle before checking. Oil should be at the recommended level, neither too low nor too high. Low oil causes wear and overheating, while excess oil may create foaming and leakage. Always use the correct lubricant grade. Clean tools prevent dirt entering the gearbox. 18. When should gearbox oil be changed? Gearbox oil should be changed according to the manufacturer's schedule, operating hours, oil condition, and machine environment. Heavy loads, high temperature, dust, moisture, or continuous operation may require earlier oil replacement. Oil should also be changed if it becomes dark, contaminated, smells burnt, or contains metal particles. Regular oil analysis helps decide the correct replacement time and prevents internal gear damage. Clean oil improves cooling, protection, and gear life. 19. What is gearbox alignment? Gearbox alignment means setting the gearbox, motor, coupling, and driven machine in the correct position so their shafts rotate on the same center line. Poor alignment causes vibration, bearing wear, coupling damage, oil seal failure, and gear tooth stress. Alignment is done using straight edges, dial indicators, laser alignment tools, and proper shimming. Good alignment increases machine life and reduces maintenance cost. Correct alignment directly improves gearbox reliability. 20. What safety precautions are needed during gearbox maintenance? During gearbox maintenance, the machine must be stopped, isolated, locked out, and tagged out before work begins. Hot oil, rotating parts, heavy covers, and sharp gear teeth can be dangerous. Technicians should wear gloves, safety shoes, eye protection, and follow lifting procedures. Oil spills should be cleaned quickly. Never inspect a running gearbox by opening covers unless the manufacturer specifically allows it. Safety must come before maintenance speed. 21. What is preventative maintenance of a gearbox? Preventative maintenance of a gearbox includes regular inspection, oil level checking, oil replacement, leak checking, bolt tightening, vibration monitoring, temperature checking, alignment inspection, and cleaning breathers. It also includes checking unusual noise, bearing condition, and gear tooth wear. The main purpose is to find small issues early before they become major failures. Preventative maintenance improves reliability and reduces production downtime. Documented maintenance history also supports faster future troubleshooting decisions. 22. What is predictive maintenance in gearboxes? Predictive maintenance uses condition monitoring tools to predict gearbox problems before failure happens. Common methods include vibration analysis, oil analysis, thermography, ultrasonic testing, and trend monitoring. Instead of changing parts only by schedule, technicians study real machine condition. This helps avoid unnecessary maintenance and prevents sudden breakdowns. Predictive maintenance is useful for critical gearboxes in continuous production plants and heavy industries. It supports accurate data-based maintenance decisions. 23. How do you troubleshoot a gearbox problem? To troubleshoot a gearbox problem, first observe symptoms such as noise, heat, vibration, leakage, low performance, or abnormal load. Then check oil level, oil condition, mounting bolts, alignment, coupling, bearings, seals, and gear teeth. Use inspection tools like temperature guns, vibration meters, dial indicators, and oil analysis. Always compare findings with manufacturer limits. A systematic approach prevents wrong diagnosis and unnecessary part replacement. Good records improve future troubleshooting accuracy. 24. What are the signs of worn gear teeth? Signs of worn gear teeth include abnormal noise, vibration, backlash increase, metal particles in oil, poor contact pattern, scoring, pitting, cracks, and reduced power transmission. Worn teeth may also cause jerky movement or uneven load sharing. During inspection, gear tooth surfaces should be checked carefully under good light. If wear is severe, the gear should be replaced before complete tooth failure occurs. Early replacement prevents sudden breakdown and machine damage. 25. How can gearbox life be increased? Gearbox life can be increased by using the correct lubricant, maintaining proper oil level, avoiding overload, ensuring accurate alignment, controlling temperature, preventing contamination, and following regular maintenance schedules. Operators should report unusual noise, vibration, or leakage early. Proper installation, correct coupling selection, and clean working conditions also improve life. A well-maintained gearbox runs smoothly, saves energy, and reduces unexpected repair costs. Good operation habits protect internal components. Gearbox interview preparation becomes easier when you understand both basic theory and practical maintenance points. Interviewers usually prefer candidates who can explain speed reduction, torque increase, lubrication, alignment, backlash, bearing failure, noise, overheating, and troubleshooting in simple technical language. These 25 Gearbox interview questions and answers cover the most important areas asked in mechanical, automobile, production, and industrial maintenance interviews. Revise them carefully, connect each answer with real machine examples, and speak confidently. Strong practical understanding can make your interview performance much better and more professional overall today.